Dear students, in the last class we learnt about the covalent bonding and the formation of single covalent bonding and multiple covalent bonding. In that we have to know about that what is covalent bonding. It means it is defined as the force of attraction that binds two atoms together due to the shared pair of electron. Here it means there will be a mutual sharing of electron between the two atoms. Okay, next, formation of single covalent bond. Here there is mainly we have to know about that atomic number of atoms, electronic configuration, and how many valence electrons should be present in the outermost shell. Here they are giving hydrogen molecule. In that hydrogen in the outermost shell they have one electron is present. For one hydrogen it is one electron should be present in the one hydrogen, and other hydrogen have a one electron. Okay, when it is actually bonding it gives hydrogen single bond. Okay, and one of the example for single bond is hydrogen chloride also. Here in that these two electrons should have when it means the hydrogen have one electron and chlorine have 7 electron. The hydrogen of one electron and chlorine of one electron mutually shared, it forms a single bond. This contains this electron should also belongs to Cl, and these 7 electrons should also belongs to the H. Okay, so the total number of hydrogen has 8 electrons and total number of chlorine has also 8 electrons. Okay, next is formation of multiple bonds. They have 3 types, that is sigma, pi, and a covalent coordinate bond. Sigma means which is actually overlapping. Pi means laterally overlapping. In that we know that sigma bond it is a single bond. For pi bond there will be present on double bond and the triple bond. Sigma bond is independent but pi bond is dependent on sigma bond. Okay, next, covalent coordinate bond. It means it is a type of covalent bond in which shared pair of electron belongs to one of the bonded atoms only. Here I was explained, it means that both the electrons should be have the same electrons are carried. Here hydrogen has 8 electrons and also chlorine has 8 electrons when it is mutually sharing. Okay, but according to covalent coordinate bond it should be only belongs to one atom. Here hydrogen has 8 electrons or it may be chlorine has 8 electrons. Okay, next there I was explained 2 examples. One is formation of oxygen molecule. Oxygen to oxygen there I have a double bond and nitrogen triple bond. Okay, in that you have to know about that in the outermost shell carbon has a 4 valence electron, it has a 4 bond pair. It means it forms only bond pair. Okay, next, oxygen has a 6 electrons, they have a 2 lone pairs and 2 bond pairs. Nitrogen have a 5 electron, it has 2 lone pair and the 3 bond pairs. Okay, next we move on to the factors affecting of the formation of the covalent bonding. Okay, next is factors affecting the formation of covalent bond. There are 4 factors are there that affect the formation of covalent bond. First one is electron affinity. First one is electron affinity. In that we have to know about that. Before going to the how the electron affinity affect the covalent bond, we have to know the what is electron affinity. Electron affinity means it accepts the electron. Okay, that is called it as a electron affinity. Okay, it is how now we will know about the how electron affinity will affect the covalent bond. Here a covalent bond is generally favored between the two atoms. Okay, next, if both the atoms have the high electron affinity. Okay, here they are saying a covalent bond is generally favored between the two atoms. You all know about that. Here X and Y is there. X, it will donates 1 electron, and Y, it will donates 1 electron. They are mutually sharing, they form a single bond. Okay, if both the atoms have the high electron affinity, I was explained electron affinity means it accepts the electron. Here X is accept the electron from Y and Y is accept the electron from X. Here the mutual sharing is formed. Okay, so that's why they have a both electron affinity. In these two atoms they have a electron affinity, so that's why electron affinity is directly proportional to covalent bond. Formation of covalent bond, it means for formation of covalent bonding they have a high electron affinity. This is all about the one factor that should be affect the covalent bonding. Next, second one is ionization energy. We have to know about what is ionization energy. It means the amount of energy required to break the bond. Okay, the amount of energy required to break the bond, that should be called it as a ionization energy, or it may be the amount of energy is required to remove the outermost shell of the electron. This is one of the definition. Or the amount of energy, another definition is the amount of energy required to remove the outermost shell of the electron. This is the two definitions is there, to break the bond or to remove the outermost shell of the electron. Now we will know about the how ionization energy should affect the covalent bond. Here ionization energy of both the atoms participating in bonding should be high. Here it means the ionization energy should also be a high for covalent bonding compounds. Okay, next, third one is atomic size. Okay, how will affect the atomic size of atoms for covalent bonding? Here atomic size of the atoms forming covalent bond should be smaller. Forming covalent bond should be smaller. It means for the covalent bond formation atoms, it means here we are taking X and Y. This is the covalent bond. The atomic size of X and Y should be smaller. Okay. In that, smaller the atomic radii, atoms, more stronger the covalent bond. Okay, in that it means when atomic size increases, atomic radii also increases. Okay, because the electron should be added to the different shells. If atomic size is decreases, the atomic radii is also decreases. Okay, for example, for hydrogen molecule, hydrogen bond is more stronger than Cl molecule. Did you get it? More stronger than Cl molecule. Here hydrogen as the atomic number is 1 and it is approximately the atomic size is also 1 and chlorine is 35.5. Okay, the atomic size. Here compared to a hydrogen and chlorine, hydrogen has the less atomic size, chlorine has the high atomic size. In the formation of hydrogen molecule, bond is stronger than the chlorine because chlorine has the high atomic size. Okay, this is all about the atomic size. Next, we move on to the fourth one is electronegativity. Electronegativity. You know that electronegativity means when the atom should accept the electron, it release some energy. Okay, so that will be called it as electronegativity. It how the electronegativity affect the covalent bond is the electronegativities of both the atom. Electronegativities of both the atoms should be high. It means the difference between the electronegativities value. Electronegativities between the atoms, between the two atoms should be minimum. Did you get it? Here the electronegativity of both the atoms should be high. When the electronegativity is high, the difference between the electronegativities of the two atoms should be minimum. Okay, here the electron affinity has high. Next, ionization energy is also high. Next, atomic size is smaller size. Next, electronegativity is high. Okay, this is all about the factors affecting the formation of covalent bonds. Okay, next we will move on to the VEPR theory. VEPR theory. It means the expand form is valence shell electron pair repulsion. Here you have to know that V means valence, S means shell, E means electron, P means pair, R means repulsion. Here the electrons are present in the valence shell. Electron pair present in the valence shell, there will be a repulsion is there for the molecules. That should be minimize the repulsion by using VEPR theory. It means it minimize the repulsion. It minimize the repulsion of electron pair present in the valence shell. Okay, valence shell. Some examples are there in that. First one is shape of ammonia molecule. Ammonia molecule NH3. Before going to this, we have to know about this VEPR theory. When the electron pair should be present in the central metal atom, it means for more number of atoms should be attached to the one single atom, that is called it as a central metal atom. Okay, more number of atoms should be bonded with a single atom. That single atom is called it as a central metal atom. When the electron pair should be present in the central metal atom, the shape will be distorted. Okay, if in case there are 4 number of electrons should be present in the central metal atom in the valence shell, the shape is tetrahedral usually. But when the lone pair of electrons is present, the geometry of it means the shape of the molecule should be distorted. Distorted means changes. It may be square planar or it may be distorted triangular. Okay, and bond angles also should be the distorted. Bond angle should be also distorted. Changes will be occur. That should be explained by VEPR theory. It means it explains the distorted angle and a shape. Okay, in that we have to know about that in NH3 the 3 hydrogen atoms should be bonded with the nitrogen atom. First we have to know about the nitrogen. Atomic number is 7 and electronic configuration is 1s2, 2s2, 2p3. Okay, in the valence shell there are 5 electrons are there. Valence electrons is 5 electrons. Okay, in that here there are these 5 electrons undergo sp3 hybridization. Here 4 sp3 hybrid orbitals are formed. Here 4 sp3 hybrid orbitals are formed. sp3 hybrid orbitals are formed. In that 3 sp3 hybrid orbitals are 3 sp3 hybrid orbitals are off-filled or off-filled and one is completely filled. One is completely filled. here you have to know about that. Here 5 electrons are there. Okay, in that there are 4 sp3 hybrid orbitals are formed. In the 5 electrons there are 4 sp3 hybrid orbitals are formed with nitrogen atoms. In that 3 sp3 hybrid orbitals are half filled. Here 2s2 and 2p3 is there. Yes, the minimum electron is 2. For p, the maximum electron should be filled is 6. Okay, did you get it? Yes for 2, p for 6 and d for 10, and f is equal to 14. In that we have to know about that. Here p should have a 3 electrons. In the 6 they have a 3 electrons, it is half filled. Okay, in that 3 sp3 hybrid orbitals are half filled and one is completely filled. Here 2 electrons is there for s orbital. This is completely filled. Did you get it? This is half filled because 3 electrons are present in the instead of 6. Here 2 electrons is present, it is completely filled. Here these 3 sp3 hybrid orbitals, 3 sp3 hybrid orbitals are bonded with 3 hydrogen atoms. Are bonded with 3 hydrogen atoms and one completely filled, form lone pair of electrons. Okay, here you have to observe this. These 3 sp3 hybrid orbitals should be bonded with the 3 hydrogen atoms and one completely filled hybrid orbital form lone pair of electrons on nitrogen atoms. The structure is like this: N, H, H, H. There is a lone pair of electron is there. Okay, here this is a one lone pair of electron. The bond angle is 107 degree, but when the presence of 4 hybrid orbitals, the bond angle should be 109 degree 28 minute. Okay, but here there is 107 degree 48 minute. 107 degree 48 minute. In that the bond angle should be distorted. Distorted means changing. This changing will explain by VEPR theory. In that we know that here there are 3 bond pairs and one lone pair is present. Did you get it? In that I will explain you again. Here shape of ammonia molecule. In nitrogen there are 5 valence electrons should be present. Here 4 sp3 hybrid orbitals are formed. In that 3 sp3 hybrid orbitals are off filled. Here p orbitals are 3 hybrid orbitals, that is off filled, and one is completely filled. Here s is completely filled. So in that 3 hybrid orbitals are bonded with the 3 hydrogen atoms and one form the lone pair of electrons on nitrogen atom. Okay, when the presence of 4 hybrid orbitals, the bond angle should always be 109 degree 28 minute. but here it gets 107 degree 48 minute. Here the change will be occur. This change will explain by VEPR theory, and here there are 3 bond pairs and 1 lone pair is present, and the shape is pyramidal. Okay, this structure is also written here like this. p orbitals, you know that there will be dumbbell shape. Here I am writing nitrogen. p orbital is bonded with a 1 hydrogen atom. You know that p orbital, the shape of p orbital is dumbbell shape. S orbital is spherical, and d orbital is double dumbbell shape. And this is the lone pair of electron. Okay, this is all about the shape of the molecule. Here one hydrogen and other hydrogen. Okay, this is all about the shape of ammonia molecule. The shape is pyramidal.